Okay, hello and assalamualaikum everyone. Good morning. All right. So this week we're going to continue our discussion on exercise 2. Okay, so we will continue our discussion on exercise 2 and then we will move on to look at our example from last week's lecture. Okay. All right. Okay. So first, on question 1 that we discussed last week, okay, so some of your friends, okay, give a different answer for this part, okay, so the final part here, okay, no cars waiting for service under the new system, okay, so actually, okay, some of your friends got it right. Okay, no cars waiting for service under the new system. Okay, so you should include the probability of being in state 2 as well. Okay, so if pi naught plus pi 1, it basically means this one refers to the probability that that the new arrival don't have to wait for service. Okay, so for this case, okay, the probability that no cars waiting for service, so it can include probability of being in state 2 as well, because in state 2, okay, so there are two cars in the system, both being served by the server, because you have two servers. Okay, so in state 2 you have two customer in the system or two cars in the system. Okay, so basically means both are getting served and there are no cars waiting for service. Okay, so if the question say that calculate the probability that the new arrival don't have to wait for service, then only we will calculate our pi naught plus pi 1. Okay, so for this question, okay, some of you gave me this answer, okay, last week. So actually we should include probability of being in state 2 as well. Okay, so it should be pi naught plus pi 1 and then plus pi 2. Okay, so some correction from our discussion last week, right? Okay, so next let us continue to question 2. So for question 2, you have a machine repairing company. So workers first must get their tools from the tools center, okay, which is staffed by a single person. Okay, so the mean number of workers asking for tools be 5 workers per hour and the average time taken to handle one request for tools be 10 minutes. Okay, so the server, okay, is paid $5 per hour and each worker is paid $8 per hour. Okay, so the server basically complained that he or she is overloaded, okay, and many workers waste their time queuing for tools. Okay, so then the senior manager wonder if it is cost effective to employ an extra server. Okay, so first what you have to do, okay, you have to determine the model for the existing system. Okay, so any volunteer for this question? For the existing system first. Okay, so you want to determine the average cost per hour of providing tools. Okay, so this will include the cost of time lost by the workers and the cost of employing the tool distributor. Okay, so is there any volunteer for the existing system? All right, okay. Okay, Lukman, go ahead. Okay, so you're looking at the value of waiting time, is it? W. W, right? Okay, so let us first look at your model. So MM1Q, okay. So your C is equals to 1, okay, because MM1. So your lambda, you use the unit minute, is it? Okay. So you use minute, so you should get, which one is your lambda? 5 over 60, is it? 1 over 12. Okay, so 1 over 12 per minute or 5 per hour. Okay, so if you use unit hour, so you should get 5 per hour. If you use minute, you should get 1 over 12. So then your mu is 1 over 10. Okay, so if you use hour, you should get 6 per hour. Okay, so if minute, 1 over 10, right? Okay. So next, you calculate your rho, lambda over mu. So you get 5 over 6. Okay, so for your rho, regardless of the unit that you use, minute or hour, so you should get 5 over 6. Okay. And then you're looking at the average number of workers in the system, right? So that should be our L or LC. Okay, so L, so you will get 5 workers per hour. Okay, so up until now, okay, so 5 workers per hour. Okay, and then for the average cost per hour, okay, loss of cost per hour. Why is it that you look at the value of W? Sorry. Why is it that for average cost you look at the value of your W? The first part you calculate 5 times 8, right? Okay, so 5 times 8 refers to because it's idle, right? So 5 workers is idle. Okay, the second part, what is it that you calculate? 5 times 50 minutes. What is that? Okay. All right. Okay. All right. Okay, never mind. Okay, so good job until 5 times $8. Okay, so average cost of 5 times $8 basically since 5 workers are idle per hour. So basically you lose $40. Okay, so 5 times 8. Okay, you pay them. Okay, but then they are idle waiting for their tool. Okay, but for the second part, actually you just have to add on. Okay, so the pay for the server, which is $5. Okay, so you pay the server $5 per hour. So actually for the second bracket there, okay, so you just add on 5 times 8, which is 40, and then plus the payment for your server, which is $5. Okay, so the cost would just be $45. Okay, all right, okay, good job, Lukman. Okay, so then, okay, so next, what the manager want to do is he wants to see whether he should employ a second distributor or not. Okay, so anyone wants to volunteer for the new system for us to investigate the measure of effectiveness for the new system? So what do you think the type of model for the second part? Because
MMC.
MMC, so what is your C?
Two, silver.
2. Okay, so can you calculate right now your row for MM2Q? What is your row for MM2Q? Okay, so you have your queuing system, which is MM2. Your C is equals to 2. Okay, so can you calculate your row?
Lambda over C mu.
Okay, so what is the value for lambda over C mu?
5 over 12.
5 over 12. Okay, so for the second part where the manager wants to investigate the new system, okay, so you should get your model as MM2 and then your row is equals to 5 over 12. Okay, so next what you have to do is you have to calculate your L. Okay, so what is the formula for L for MMC?
L tu yang LQ ke LC tu? L.
LC. L is LC. I think I make the correction, right? LC should refers to L. Okay, so for question 2, the first one that Lukman shared just now is MM1. Okay, so and then Afif said the new system is MM2. So your row is lambda over C mu equals to 5 over 12. So you want to calculate your L or your LC. So what is the formula for your L for MMCQ?
Yes, sir.
Yeah, so what is the formula for your L or your LC?
Lambda WC.
Lambda?
WC.
Lambda WC. Okay, so how are you going to calculate that? Anyone
Uh,
want to help out? Afif, so what's actually the formula for your L or LC? Okay, so thank you, Afif. Okay, so we got up until our row. So next we have to calculate for our L. Okay, so thank you, Afif. Anyone want to help out, Afif? The formula for your L is given to you already in the video. So how are you going to calculate your L?
Doctor,
Yeah.
the L for the formula is RC rho pi naught divided by C factorial in brackets 1 minus rho squared.
Which model are you referring to?
MMC, Doctor.
MMC. Okay, so your L. So you just substitute your C equals to 2. What should you get?
Hold on, Doctor, I'll calculate it.
Yeah. Okay, everyone please do the same. Try and calculate the value of L. Okay, by substituting into the formula. So you have your C equals to 2. Okay. And then substitute your rho and then try to calculate for L. Okay, so anyone who have answer can share your solution. Okay, just substitute. Okay, so you have your C equals to 2. Okay, and then just substitute your R. R is lambda over mu. Okay, so and then you have your rho, which is 5 over 12. So what should you get for your L? So you can give me answers in decimal or fraction. Sorry, what is the value of your pi naught for MM2Q? With rho equals to 5 over 12. So what is your pi naught? Anyone? 0. Lukman got 0.3307. Okay, anyone else? Okay, so Lukman, you have your pi naught. Can you proceed with your L? 7 over 17. Okay. Yeah, just proceed and calculate now. Okay. So Gao Lan Lan get her pi naught equals to 7 over 17, right? So that should be 0.4118. Okay. And then Gao Lan Lan said the L is equals to 120 over 119. Okay, so anyone else wants to share your solution for pi naught and L for the new system, MM2Q? Ainul, did you try and calculate? Just substitute in the formula. Okay?
Hello, the
Yeah. Did you try and calculate your pi naught and L for the new system?
still calculating, the
Alright, okay. So anyone have complete their calculation for pi naught and also L? Okay, so Jack gets the pi naught equals to 7 over 17, L 120 over 119. Okay, same with Yilin. Okay. Okay, so for the new system, okay, so we have MM2Q. Okay, so this is MMC. So your row, okay, so you should get your rho is lambda over 2 mu, which is 5 over 12. Okay, and then for your pi naught, so you have to substitute in the formula. So you should get I equals to 0 until 1, r to the power of I factorial. Okay, so and then plus RC over C factorial 1 minus rho. Okay, so 1 over. Okay, did I get the right formula? Right? Okay, So this is for your pi naught, okay? So you get 7 over 17, okay? So you should get 7 over 17 or 0.4118. Okay, and then for your L or your LC, you just substitute in the formula, okay, based on the value that you have. So you should get 120 over 119, okay, so or in decimal 1 over 0.008, okay. So next, what you have to do, okay, so basically this is the number of worker in the system per hour. So basically 1.008 worker per hour, okay, in the system. So next, you have to calculate the cost of time lost by the workers in the new system, okay. So you have the workers is paid, you have 1 workers, okay. So 1.008 times they are paid $8, okay, and then plus, okay, the payment for your 2 server, okay, so 2 times $5, okay, so you should get 18.07 okay, compared to your MM1, okay, previously. So the cost is $45. Okay, so basically you can answer the question, okay, so should the plant manager employ a second distributor, okay, based on the cost lost, okay. So the cost lost per hour, okay, when you have two distributor, two tools distributor, okay, is less than when you have one. Okay, so they should consider to employ a second distributor, okay, to make the system more efficient so that less workers are waiting per hour to get their tools. Okay, so that is for question 2. Okay, so everyone okay with question 2? So no questions for question 2. Okay, so try and do the calculation. The formula is given to you. Okay, so for your test and also for your final exam, okay, since we start learning a lot of formulas, so you don't have to panic in terms of memorizing all of the formula. Okay, so because in your test and also in your final exam, the formula will be given to you. Okay, unless the question asks you to derive, then you have to derive it on your own. Okay, for this kind of questions, okay, you just have to substitute the value of your parameter into your formula, because the formula for each of the model will be given to you during your test and also your final exam. Okay. So before we move on to question 3, okay, so I want to go through our lecture for last week, okay, our lecture 4, because there are some correction, okay, in the video. I'm not sure if you notice or not, okay. So for lambda I here, okay, so I think the one in your notes is correct. It's just that when I write it in the video, okay. So for your lambda I here, your I should start from 0 until k minus 1. Okay, I think the one in your notes is correct. Okay, so please double check. And then on slide, this slide, okay, it should be your pi I, not pi note here. Okay. Okay, so that is some of the corrections from last week video. I just noticed the typo, okay, in the video. Okay, so please tally back the one in the video and the one in your lecture notes. Okay. All right. Okay, so that is on the correction before I forget. Okay. So let us go back to question 3. Okay, so for question 3, basically what you have to do is you have to check, okay, the average number of men in the system or away from their productive work when you have 1, 2, or 3 inspector. Okay. Okay, so for question A, when you have 1 inspector, okay, so anyone wants to volunteer for question A? But you can hear me, right? Can you hear me, Azra? Okay, so you can just type your answer for question 3A. You don't have to share if your connection is bad. So can you share your answer in the chat box for question A? You want to find the average number of men in the system away from their productive work, okay? When you have one inspector, one quality control inspector. So for question A, so what is the average number of men in the system? Can you share your answer in the chat box, Azra? You get your LQ equals to 5.33. What is the value of your rho? Lambda over mu. What is the value of your lambda over mu? 4 over 3. Okay, so this is MM1Q, right? Okay, so you get your rho. Okay, so for question A, okay, so MM1Q. Okay, so you get your rho. Okay, lambda over mu is equals to 4 over 3. Okay, so for MM1Q, okay, is it allowed for you to have the value of your rho greater than 1? Okay, Chenny, can you have your rho greater than 1 for infinite QE model?
No, okay.
All right, okay. So, okay, Yilin also said no. Okay, so for infinite QE model, the first thing that you have to do is you have to check for the value of your rho. Okay, so if it is greater than 1, then you cannot or you don't have to calculate for the rest because no steady state solution exists because your rho is greater than 1. Okay, so hence the number or your Q will just increase. Okay, and then the system will never reach its steady state. Okay, so for A, MM1Q, your rho is greater than 1. Okay, so no steady state solution. Okay, so first please be careful and check for the value of your rho first. Okay, so basically for A, okay, so you will not have a steady state solution because the value of your rho is greater than 1. Okay, right, so thank you Azra and also Chen Yi. Okay, so let us move on to B. So for B, it is MM2Q. Right, you have two inspectors. Okay, so for question B, what is your pi note? Okay, so Yilin said 1 over 5. Anyone else? 1 over 5, Murshida. Okay, Chai Wen, now file. Okay, so for B, pi note is equals to 1 over 5. Okay, and then your L, okay, which means the average number of men in the system, your L or your LC should be equals to, what did you get? Okay, so right, good job. So I know Haris also get 0.2 for pi note. Okay, and then for your L, what did you get for your L? Okay, so Mushida said 1.067, Yilin 2.4, Chai Wen 12 over 5. Which is 12 over 5 is equals to 2.4, right? Okay, so I know get 1.067. Okay, now file get 16 over 15. Okay, so we have three answers so far. Okay, so the first one would be 2.4 and then 1.067. Okay, 16 over 15 in decimal is 1.067. Okay, so two answers so far. Okay, so Jack gets 12 over 5 or 2.4. Okay, so my answer, okay, what I get is equals to 2.4. Okay. So in case you get a different answer, okay, so please double check your substitution into the formula. Okay, and let's say you still cannot get 2.4, then you can let me know. Okay, so for your L, you should get 2.4 for B. Okay, so your pi note is 1/5 and then your L is 2.4, right? Okay, and then for C is MM3Q, sorry, MM3Q. Okay, so what is the value for pi note for C for MM3? So for question C, you have 3 inspectors. Okay, so what is the value of your pi note? Okay, so Chai Wen, Kok Ping, so everyone give the same answer, which is 15. Okay, now file, so 15/59. Okay, so 15/59. Okay. Okay, the same with 0.2542. Okay, so for question, okay, so the one in decimal, okay, the answer in decimal is given by Ainul and Haris. Okay, and then if you were to write your solution in fraction, so you should get the one shared by Chai Wen, Kok Pin, and Naufal. Okay. So for your pi note, you should get 15/59 or 0.25 for 2. Okay, so what about your L? Okay, so good job on pi note. Okay, for part C, so what about your L? Average in the system, your L or your LC. Okay. Okay, so 436/295. Okay, so or 1.478. Okay. Okay, so that's the answer shared by Chai Wen. Anyone else got different answer? Or if you have the same answer also, you can type in the chat box. Okay. So for question C, MM3Q, okay, so for your L, you should get, okay, so 1.478. Okay, so thank you, Chai Wen, and the rest of you who have shared. Okay. So this should be the answer for your A, B, and C. Okay, so next what we want to do is we want to find the values of C and D when it's worth employing 3 inspectors rather than 2 inspectors. Okay, so for C, denote the hourly pay for an inspector, and D is the hourly loss from having a workman idle. Okay, so anyone wants to share the values of C and D when it's worth employing 3 inspectors rather than 2 inspectors? So basically what you have to do here is you have to make sure, okay, as long as the hourly pay for the inspector is less than the hourly lost, then it is worth it to employ an extra inspector. Okay, as long as the hourly pay for you to pay for the inspector is less than the hourly lost, okay, when you have the workman idle, okay, then only it will be worth it to employ an extra inspector. Okay. Right. So what you have to do here, okay. So you have C. Okay. So this is the hourly pay for your inspector. Okay. And then what you have to calculate next is your hourly lost if you have 3 inspectors instead of 2. Okay, so in order for you to do that, okay, so you have to take the value of your L when you have 2 inspector. Okay, so your L for your 2 inspector minus your L for your 3 inspector. Okay, so this value here is equals to 2.4. Okay, minus 1.478. Okay, so which will gives you, okay, the difference is 2.4 minus 1.478. Okay, sorry. 2.4 minus 1.478, okay, is equals to 0.922. So your hourly loss, okay, the difference, okay, for your hourly loss, okay, if you have 3 inspectors instead of 2, okay, so 0.922 times, okay, the value of D, okay. So as long as your C is less than 0.922 times your D, then only it will be worth it to employ an extra inspector. Okay, so this should be your answer for the final part. Okay, or your C is should be less than 0.922 D. Okay, right? So that is the final part for question 3, exercise 2. Okay. So everyone okay so far? Okay, so how many? Okay, so times, we have 3 minutes left. Okay. So that is on your exercise. So those who did not attempt, so please do so. Okay, I already provide you with the answer. Okay, so you can double check. Okay. Please do so. Don't assume that you understand. Okay, when you look at your answer or when your friends share, when I explain, do not assume you understand up until you attempt and try and then manage to get the solution. Okay, so if you have any questions, so you can contact me so that I can help you out. Right? Okay, so before we end, okay, so let us go through our lecture note from last week. Okay, so for our MMCK, okay, so let us double check our answer for example 4.2. Okay, so example 4.2. Okay, so your row is equals to 2, not equals to 1. So what is the value of your pi note? 1/1141. Okay, 1141, or in decimal, I think it's very small, 0.00088, something like that. Okay, all right. So thank you, Yilin, Ain, and also Ainol. And then what is the value for your L? Right, okay. So for your L, you should get 6.06 or 0.5 is also acceptable. Okay. Cars per minute. I think Yilin is per hour, I think. Your answer is in per hour, right? You use hour, is it? If you use minute, you should get 6.06. Same as Ain and Chai Wen. Did you use hour, Yilin, as your unit? Okay, so, all right, okay, never mind. Okay, so double check. Okay, so the question asks you to use the basic time unit. Okay, so please check. So for L, you should get 6.05 or 6.06. Okay, all right, never mind. Okay, so good try. Okay, so just recheck because it's a lot of substitution in the formula. So make sure you do your calculation right. Okay, so as long as you have the right formula, you manage to identify the correct model, so you should be able to get the marks. Okay, usually the substitution and the final answer, okay, it is still important, but it is much more important that you should be able to identify the correct queuing model. Okay, so and then for question 2, we want to find our W. Okay, so what is the value for our W? 12.24. Yep. Okay, so for W, okay, so you should get 12.24 minute. Okay, so it's in minutes. Okay, 12.24 or 12.23, something like that. Okay. So Amira also said 12.24. Yep. Okay. Okay, good job on that. Okay, so next. Okay, so lambda times pi 7 where we want to find the expected number per hour that cannot enter the station because of full capacity. So what is the value of this one? Okay, so because pi 7, okay, so the probability of being in state 7 actually represents the fraction of customer that did not manage to enter your system. Okay, so now we want to calculate the average number that cannot enter the system. Okay, so what did you get? Okay, so you should get, right, okay, 30. Okay, so you should get 30.29 per hour. Okay, because the question asks you in hour, you have to times 60. If per minute, then you divide by 60. Okay. All right, so that is all for this week's discussion. Okay, so thank you all for attending and for your participation in the discussion. Okay, just a reminder. Okay, so you have to submit your assignment 1 tomorrow. Okay, by 12 p.m. Okay, and also good job on completing your online quiz 1. Okay, so please remember to submit your assignment 1. Okay, and then I will upload all the materials for this week by tomorrow. If there's any delay, I will inform to you on eLearn as well. Okay, so all right, thank you. So I'll see you guys next week. Okay, before your break. Okay, so next week on Monday we'll also have our discussion. Okay, so I will upload exercise 3 once we completed our lecture for this week. Okay, so then I will see you guys next week. Any announcement, please refer to your eLearn. Okay, so thank you everyone. See you guys again.